Okay, this should be the second week, first session on the second week, either Monday or Tuesday, depending what period you're in. Okay, we're going to be continuing with the packet. I think we left off on this parallelogram, or triangle or square, depending on how you view it. Right, parallelogram, triangles and squares. And you have to kind of know all three, actually, to answer the question. Well, 2 out of the 3 probably, right? Anyway, so we ended with 19. The assignment for this is 20 to 27. Again, on each posted assignment, I'm posting the whole document in terms of the PDF, but in the assignment, I'm telling you which ones to do. So don't do them all, just do the ones that you're doing. Now, some of you I noticed what you're doing is you're just doing you're doing it on the whole document, and then you're keeping it going, and then you're submitting the whole document. That's fine. And then some of you are just doing on a separate sheet of paper the ones. It doesn't really matter to me at all how you're doing this, and you probably noticed that all semester, all last semester. I'm trying to be as open as possible to however you're submitting them, as long as you're doing the work and turning it in, right? 1 second, I left the markers on the other board. Anyways, we're going to be working on this packet all week while I'm out and recovering from surgery. Hopefully, the following week, which I don't know the dates. I'm getting confused by the dates. But anyway, so a week from today, hopefully I'll be back, and then we will start back on regular curriculum. For the advanced topics classes, that means going back to radian measure and degree measure and circle measure and the wrapping function and you know, going around a circle and all that. And then for the CP class, we're going to start the chain rule. And it is the big rule of calculus in terms of doing work. The big rule is the derivative itself, but this is a very specific rule about how to take derivatives of certain things, and it's a big deal. So anyways, hopefully a week from now I'll be back, I'll be live, and in person and all that. Oh, I mean not in person per se, but there's a chance we might be in person, right? We might be in person when I come back. It's kind of weird, right? Now, I'm going to go away on the 10th, and then it's possible that when I come back, I'll be actually here with kids, which would be really, really exciting. So, and then again, I don't want to be overly optimistic here. I don't know when the Archdiocese is going to okay us to go back, but could be soon, and that's kind of exciting. I think, especially for most of you who are seniors, that it might be nice to hopefully have some opportunities for in-person activities, and I don't know, just it would be kind of cool. Anyway, so let's get started on the assignment for today. 20 to 27, and then of course we're going to do another packet on the Wednesday. That'll be a smaller one. That'll be 28 to 32, because obviously we're only a half hour, and then we'll finish up 33 to 40, and then hopefully we'll have a second packet to be able to review from with all the answers worked out by you when you get closer to your placement exam. Some schools require that you take it in the spring, some will require that you take it in the summer, some will require you take it when you get there in the fall, and some don't require it until you actually sign up for a math class. And they'll say, well, did you so? But what a lot of students do, to be honest, is take the placement test right away. That way, whenever you do sign up for the math class, that's on your record. They have it. Funny story about that. When when I first started teaching calculus back in 1994, right? So what was that? Almost 30 years ago, right? I came here in 91, so this is actually my 30th year at Alamany, right? I decided after like 2 or 3 years of teaching, probably around 1998, I'm teaching AP Calculus and my kids are doing fine on the exam, but what I didn't know is how is this class, how is AP Calculus compared to first semester calculus? So, you know, I wanted to sign up to take a calculus class at COC because I live up in Santa Clarita. And when I stopped to take the, when I went in to sign up for the class, they said, you can't take the class, you have to take the placement test. I said, but I brought my diploma and my transcripts from college. I have a degree in mathematics from UCSB. Sorry, you didn't take the placement test. Now, this is kind of weird. It was very lucky. In the office, working, was an Alamany student who I had. And they actually walked over and intervened, and then I actually had to meet with the assistant chancellor or something like that. And they waived it. But anyway, so bottom line, the point of that story is for a lot of schools, you have to take a placement test before you sign up for a math class. It has to be on your record. And so hopefully you'll have a couple of packets here to help you get through that, right? Okay, so let's get started here. Before we start, we should put ourselves in the presence of God. In the name of the Father, Son, Holy Spirit, amen. In the name of the Father, Son, Holy Spirit, amen. So, number 20, and actually, just to be clear, we're going to do 20 to 27 today. Probably should have made that more prominent. I don't know if I'm too lazy to erase the 20. This is the video, the lecture on 20 to 27. Okay. If f of x is 2 minus x squared plus x to the third, and f of a is 2, what could a be? So remember what this is. Remember the idea here. You've got this function, and the way functions work, of course, is you put something in and then something comes out. In this case, we have this function box where if I put x in, 2 minus x squared plus x to the third comes out. So when I put x into the machine, I get that out. Now what they tell us is that when I put a into the machine, which would just be changing this to an a, they tell us quite specifically that what comes out is 2, which is a little bit problematic. Okay, it's not a super big problem there. Now, what comes out is a 2. So most of you guys could probably realize that. Well, that means when I put the a in, that equals 2. Now, remember, when you put something into a function, only one thing can come out. But what's important to note is I can put something in and I can get a number out, and I can put another number in and I can get that same number out. It can't go the other way around, right? You can put several different values in for x and get the same number out, but you can't put one thing for x and try to get 2 things out. You know, so what's going to happen here, here's my point. We're going to probably see that a can be 0 pretty quickly, but then we have to realize that a could be some other numbers. We have to make sure we get the right ones. So what we see is, so if I move the 2 over, I get 0. Now, I don't like that order. That's just personal preference. This step, of course, is totally optional. And I know some of you can probably do the question in your head at this point, and I get that. but I'm gonna grind out the algebra here, okay? So, and like anything in math, if you can see it, then you're there, right? As long as you're not, copying it off your neighbor. That's not where you're seeing it from, as long as it's coming out of your head. Factor out the a squared. And remember, we talked about this on the last video, I think, on the last video. The cool part about being equal to 0 is something times something is 0. That means either the first something has to be 0 or the second something has to be 0. And remember, that only works for 0, right? If that were any other number, you wouldn't get that beauty, right? If I had something times something is 1, there's an infinite number of ways for this to be 1. I could do 1 times 1. I could do -1 times -1. I could do 1/2 times 2. I could do 3 times a third, 4 times a fourth, 5 times a fifth. You probably see where I'm heading with this, right? But something times something is 0. The only way that happens is if you're the first thing is 0, the second thing is 0. Again, you probably go, Mr. Peters, you keep telling us that, like you're all find that all interesting. I find that interesting, okay? I think that's cool. 0's got some pretty unique powers to it that other numbers don't have. So when will a squared be 0? Now normally you do plus or minus on that, right? Like when a squared equals 4, it'd be plus or minus 2, or a squared equals 9, it'd be plus or minus 3. But with 0, obviously, there's no plus or minus on 0. There's only one 0 that doesn't have an opposite. It's kind of weird, because because it's the identity for addition and subtraction, right? Like 1 is the identity for multiplication and division. And over here, I get a equals 1. So that's the answer then, right? So there are 2 different ways for me to get 2. Remember what's happening here is I'm getting 2. If I put 0 in, I'll get 2. And if I put 1 in, because the 1s will cancel, I'll still get 2. So those are the answers to the question there. Oh, and what letter is that? That's A as in apple. So the answer number 20 is A as in apple. Now I'll move down a little bit here. I'm going to do my best to try to keep the previous question in the video as we go along here. Square root of, this is a very common type of mistake that students make. And it's a good question. It's a good question philosophically to make sure we understand how when we square binomials, right? Because we square binomials a lot in algebra. So 21. In 21, the question is the square root of x plus, no. The square root of 3, not x. You'll see why I did that. That's my dyslexia. Because I'm gonna do the question again with x's, right? Square root of 3 squared. You guys, we learned this one, right? This is like a plus b squared, or I was going to do x plus y, but I think actually most algebra 1 and algebra 2 do this as a plus b squared. Remember, you want to think of it as a plus b times a plus b. Let me work it out right in red. And then in a minute, I'm going to put green on the board, which is wrong, so don't write that down, but I'll remind you. So we do what's called FOIL, right? First times first, outside times outside, inside times inside. So A times B is AB, and then B times A is BA, but multiplication is communicative, so that means that A times B is the same as B times A, 7 times 3 is the same as 3 times 7, right? So I'm going to alphabetize it, the squared, and if you remember, we actually had this as a formula you learned in Algebra 1 and Algebra 2. We call that the square of the binomial, right? Now, here's what students do wrong on this. Okay, this is wrong. I think Miss Sackhorn has a picture of this one up in her room, and it says if you do this, someone stomps on a kitty or something really yucky like that. Yeah. In other words, don't do this, right? you do this, I cry. Okay. What a lot of students may have the mistake of doing is they think they can just put the squares in. This is wrong. You can't do that. Now, why do people think that? Why do people think that? Because it happens like a lot, right? I've been teaching 30 years. You wouldn't believe the number of times that people try to tell me that you can just bring because you can do it with multiplication. You can't do it with addition and subtraction, though. In other words, if it were AB squared, this is okay. Now, just to make sure we got this, let's just think about this. 3 plus 4 squared. 3 plus 4 squared is 7 squared, which is 49, right? 3 plus 4 squared is 7, and 7 squared is 49. If you try to bring the squares in and do it wrong, if you do it wrong, you only get 25. That's why this is wrong. It just doesn't give you the right answer. Okay? The reason it doesn't give you the right answer, of course, is notice that you're missing the middle term here. And you could FOIL it out. 9 plus 12 plus 12 plus 16, right? First times first, outside 12, inside 12, and that does add up to 49. And not that you do it that way, of course. That's just kind of to illustrate the idea. But it does work if you had like 3 times 4. 3 times 4 squared, that's 12 squared, which is, this is a total digression, I get that, 144. But it would also be the same as 3 squared times 4 squared. 9 times 16 is also 44. This is all a digression, just to make sure you don't go 3 plus 1 and get 4. Because if you do that, you're going to get A. It's right there, right? And we've talked about that before, right? It's wrong of tests. That's called a distractor. And people that make tests love distractors. I find them vile and evil, right? I think I told you, I got thrown out of a conference at UCSB because the lecture, this is on AP Calculus, and they're talking about how there's always at least one distractor on each question. And that's very common, that's not true. And I just stood up and said, it's really wrong to have distractors. And I said, but this is really sick that you're doing this to these poor kids. If you remove the 4, in this case, and then remove the A choice, and then you tell the kids, and you have no distractors, if the kid gets 4, then they can go, how come I didn't get 4? The problem with the 4 being there is we've all taken multiple choice tests, even myself, I'm just like you. And I took the SAT just like you. Or maybe you didn't take it, but we've all taken multiple choice tests. If you do the math work and then all of a sudden that's a choice, you're going to write it down. And matter of fact, you're going to be convinced you got it right. You're like, woohoo, thank God I got the right answer, right? I tried to argue that you shouldn't have distractors on the test. Because once you put a distractor on, you're penalizing the kid that knows a little bit of math. Whereas the person that doesn't know anything and is just guessing, a person guessing still has a 25 or 20% chance, depending on whether there's 4 or 5 choices. Whereas the person that falls into that trap, they're 100% going to get it wrong. They have a 0% chance of getting it right. Anyways, bottom line, I stood up and walked out of that conference. I didn't get really thrown out. I walked out in a huff like a jackass. But anyways, bottom line is be aware that sometimes when there's a common error, like I made here, it's going to show up. So you got to remember that's a very long explanation for the way you do this question. Let me erase that. I'm going to erase all of this stuff here. That's just a digression. Hold on. This really doesn't have much to do with the question, so let me just erase this. I'm going to leave the red, of course. I think the red is good. Because in the final analysis, the red kind of shows that there's the middle term here that you would not get if you do it incorrectly. Okay, so the rule here is to write it like this. Square root of 3 plus 1 times the square root of 3 plus 1. Now, again, just like the last question, I'm going to grind out the algebra. If you can do this in your head, that's fine. And then I get it, kind of like the last question. But since I'm explaining it, I like to make sure I do all of the work here. So first times first, root 3 times root 3 is 3. Outside is root 3. Inside is root 3. So first times first, root 3 times root 3 is 3. Outside, root 3. Inside, root 3. And last times last 1. So you get 4 plus 2 root 3. This blue is kind of dying here. Let me see if I got a better blue pen. Let's see. So let me just write it again to see if this, yeah, this blue pen's a little bit better. 4 plus root 3. So the answer I get is 4 plus root 3. Now you notice that's not actually technically a choice, but it goes back to the communicativity of addition. 3 plus 4 is the same as 4 plus 3, right? So they wrote it like this, which is really weird. I don't know why they would do that. It doesn't even show up math-wise. It's kind of a weird choice for them to do that, but I didn't make the test. So that's as D as in dog. So that's 21. 22. So flipping the page. Oh, I love questions like this, but I like math. And this may not be your favorite question. Okay, let me slide over. I'm going to try to keep 21 in the picture here. The graph is of the function. This is actually something that turns out to be a big deal in calculus, and it's not easy. Which function is on top of the other function? Because what will happen in calculus is we'll do calculus, but we'll need to know which one's the top function and which one's the bottom function, and it's a big deal. Okay, so this doesn't seem like a big deal. It is. It's a big deal, and it's also hard for some kids to visualize because you have to be very careful about what you're talking about here. So for some of you, you're going to see it immediately, and others are going to have to take a few seconds to digest it. Okay, so we got a graph here. Now the advantage I have is I have colored pencils here. So we have a parabola. And a top half of a circle, okay? Now, you don't need to know that, but that's what they are, right? This is called a semicircle with a radius of 3, I think. And that is the f function. So the f function is the one in blue. And then we have a parabola, 1, 1. And then they intersect here and here. And it looks like that's like at -2 and that's at 2. Now, notice that you have to see that's at 2 and that's at -2. I think it would have been nice if they had actually given you the intersection point, but that would have been hard because the y value is probably pretty funky, right? The x value probably is 2, but the y value might be funky. I don't know that though. I haven't done the math on it. Now, here's the deal. Here's what I want to look at here. The question is, for what values is f bigger than g? For what values? The question, here's the question. When is f bigger than g? Right? When is f bigger than or equal to g? That actually makes a difference, that equal sign, not that it's a big deal, but we'll talk about that. So when is f bigger than g? Well, g, another way to say it, given the way I drew it, is when is the blue one bigger than... Now some of you are like, Mr. Peters, it's pretty obvious. Yeah, hopefully it is, but sometimes some people don't have the best visual acuity when it comes to this stuff. It's purely visual, all right? And you either see it or you don't. Now, that doesn't mean you can't figure it out. In other words, once I explain it, hopefully you'll see it, right? And if you don't know the answer to this question yet, don't panic, okay? Because because I haven't given you the answer yet. I haven't explained it yet. But there's a lot of you that probably, I bet a bunch of you probably already know the answer, right? Some of you are already, Mr. Peters, this is B. I'm going to go on to the next question, but now I got to wait for you because you're talking too much. So here's the deal. If you draw a line, which one is taller? You can see from here to here, the blue one is bigger than the red one. Now, keep in mind, if you go on the other side of this -2, the blue one is less than the red one. On the other side of -2, the blue one is less than the red one. So notice that if I'm less than -2, the red one is bigger, or the G is bigger than the F. On the other side, bigger than 2, same thing. But between -2 and 2, the blue function is bigger than the red function. So the blue function will be bigger than the red function between -2 and 2. Now, because of the equal sign, and remember I said before that equal, like if there was no equal sign here, then that would be the answer. But because there's an equal sign here, we want to include the endpoints. Now, what's going to happen in calculus what we do is we need those endpoints because what we want to do is we want to find the area of this bounded region. We call the area of a bounded region. Now, that's pretty far into the end of the AP curriculum. And the AB students have gotten this. The CP may not get to that point, okay? But anyways, so notice from -2 to 2, the red one is bigger than the blue, the blue one is bigger than the red one. But on the other side, the red one is bigger than the blue one. So that would mean that the interval or the answer is -2 to 2, which is B as in boy. Which is B as in boy. Okay, 23. 23. Oh, fractions, our favorite buddy, right? Number 23. 1 over x plus 1 over y over 1 over x plus, oh no. That would be 1, wouldn't it? Remember, something divided by something is 1, so this can't be it. This has got to be a y. Or minus. Okay, so let me slide down a little bit more and try to keep the previous question in if I can. Here. So this is y here. What does that simplify to? Now, what if it were a fraction? Like 1/3 minus 1/4 over 1/3 plus 1/4. The way you'd want to do this, and there are lots of ways. Some people would get a common denominator for the top, some people get a common denominator for the bottom, and they would work both fractions out, and it would be a nightmare. Don't do that. This question is actually not that bad. Just multiply both sides by 12, right? Multiply by a giant 12. And it makes it pretty easy, doesn't it? You get 4 minus 3 over 4. 1/3 of 12 is 4. 1/4 of 12 is 3. 1/3 of 12 is 4. 1/4 of 12 is 3. So you get 1/12. Notice you can save yourself a lot of heartache on this question by not treating them as separate questions, the top and the bottom, but realizing they have a common denominator in and of themselves. Now that wouldn't work if it was like X, Y, A, B, right? Then you'd have to do them separately, okay? But because they have a common, like these are 3 and 4 is 12, 3 and 4 is 12, you can do that. You're going to want the same idea here, X, Y. So the key to this question is to multiply both top and bottom by xy. Same thing that we did here. When I x times y, the x's will cancel. X times y, the y will cancel. X times y, the y will cancel. X will cancel. Xy times 1 over y, the y will cancel. So it's very similar to what happened here, right? Except the difference is that, oh crap, that I did it again. You guys, that's a plus sign. That's a plus sign. This is supposed to be plus. Yeah. There we go. Now, it turns out that's a choice. So notice the question actually just took one step. One step. Just multiply top and bottom by xy, and all of a sudden pops out. Just pops out, right? So, and that's the answer, and that is going to be E as in elephant. So that is E as in elephant. Next one, 24. Let me just move on down here. So number 24. Inverse functions. F of x is 5, and we had an inverse question earlier in this packet, didn't we? Where we switched the x's and the y's, right? I think it was, I don't remember for certain, but I think it was like, if it goes to the point 3,5, actually, I don't have to use my memory, right? I can, if I look back, I should be able to find it. And we had another inverse question in this, right? You think I could find it really easily, but I can't. Yeah, number 4, the fourth question on the test. It went through the point, I was right, 3,5. Yeah, okay, that's weird. I remember that, but I couldn't find the page very quickly. 3,5, so then what you do is switch the x and the y, so it becomes the 0.53. Pretty simple. This has a little more to it, but the same philosophical idea. F of x is 5x plus 1, then what would its inverse be? F of x is 5x plus 1, what would the inverse be? Now, the thing is, for most students, the issue on this question is just the verbiage, the funky way that we write math in what's called function notation. If we got rid of the function notation, I think it makes it a lot easier and students have no trouble with it, but then they have to put the function notation back. So I'm going to describe the steps here. The original function is 5x equals 5x plus 1. Now, just make sure what I'm thinking in my head. This is, I'm not kidding, this is what math people do without thinking about it, that non-math type people go, what the hell did you just do there? Y is just f of x. Y is just f of x. Now, what's true is all f of x's are y's, but not all y's are f of x's, okay? Remember, the thing with a function is it has to pass what's called the vertical line test. Remember, we talked about that over on the very first question. When I put something in, I can only get one thing out. I can't get two things out. But sometimes, like, if you have a circle, let me make sure you guys, all f of x's are y's. So you can, when you have f of x, if you have any f of x question, oh crap, I moved out the other question. Hold on, let's go back a little bit. That way the other question's still in, right? Okay, here's the deal. All f of x's are y's, but not all y's are f of x's. So here's the deal. Whenever there's an f of x, if you don't like it, just change it to y. And that's what I'm going to do here. Now, why is that true? The deal is this. Like, let's say it's something like this. X squared plus y squared equals 9. Now, that would make what's called a circle of radius 3. That is not a function because it doesn't pass the vertical line test. Okay? You cannot change that. This particular y cannot be changed to an f. But that doesn't ever happen the other way. I'm going to erase that. Okay? Now you might be curious, what was the reason for doing that? Again, what we're going to do is just switch the x and the y and we're done. Well, okay, we have to do a little more than we did than on question 4. What we want to do here is switch the x and the y. Here's the inverse. So let me make sure I write that down clearly here. This was the original equation. And this is the inverse. Okay. Now, the thing is, we need to get it in that funky notation. And sometimes that's what bothers students. See, what we have to make a note of here is just to say that another way, y is f of x. The blue y is f of x. The red y is the inverse. So it's like they're both y's, but the moment you switch them, this y goes with the original function. The moment you switch them, now this y is what we call the inverse. So then now you just do a little bit of algebra. And then you just divide by 5. So we have y equals x minus 1 over 5. That is the answer because I can swap that out, right? I can say this is y, right? So I can erase this and put f of negative 1x. That red one, if I want to, I can switch back to the inverse function. So there it is, and that's the answer, and that is E as in elephant. So that's E as in elephant. Okay, so let's see. I'm going to move the board down a little bit more. I'm getting to the end here, right? This is the last one, but I'm okay because I got more space here, so we're gonna be okay. So 25. On 25, log of 2 to the 1/4. The thing that's weird about logs is we do them so infrequently. When we're studying them and we memorize all the rules, they're not so bad. We can do them pretty easily, right? But when they all of a sudden show up out of the blue, it's like, you completely forget all the rules. Remember the basic rule here. I'm gonna call this y. The basic rule is this, guys. This is how you deal with logs. The way you deal with logs, you turn them into exponents, right? Now, that's not always true, but in this case it is. One of the common things about logs is that you need to realize it's the inverse of an exponential. Kind of like division is the inverse of multiplication. It's kind of like subtraction is the inverse of addition. Not kind of like, exactly like, they're inverses, right? But every operation should have an inverse, hopefully. Now, that's not true because some functions don't operate that way, but if they're what we call monotonic, then they do. And it turns out exponentials are monotonic. Okay, so what does that monotonic mean? It means it's always going up or it's always going down. And if you think about what these graphs look like, I don't know if you thought about that. If an exponential looks like this, it's always going up. And a logarithm, which is an inverse, is also always going up. They're called monotonic functions. Now, like a parabola, like we did earlier, or a circle, those are not monotonic, so they technically don't have an inverse. Neither the sine or cosine have an inverse technically. But what you can do, if you sometimes you really want it to have an inverse, even though it's not supposed to have an inverse, you just shrink the range down to where it is monotonic, and then you can make one. Like we do that with sine and cosine, right? We've used inverse functions before, but we can't go anywhere. We have to stay between certain numbers, right? For sine, we have to stay between negative 90 and 90, and for cosine, we have to stay between 0 and 180, right? But anyways, digress. So what we do is, here's the rule. Here's the rule that we use. Log. So in this case, the base is 2, the x is 1/4, and the y. When you rewrite it as x equals b to the y. And we just talked about this in the last question. We just switched the x and the y, right? So notice that instead of y equals b to the x, which would be the normal way of writing it, it's an inverse, so we switch the x and the y. So instead of writing as y equals b to the x, we write it as x equals b to the y, because we actually want the logarithm, which is the inverse. But this is it. This is what you have to remember. And again, one of the problems with a placement test or a cumulative type exam is, hey, you learned that back in algebra 2 or something like that, right? Or pre-calculus. All of a sudden it's a year later and you're taking the test and you're like, yeah, I used to know how to do that question, right? Because I could probably go back and look at your old tests and you probably got them right on your old tests, right? So at one point in your life you could do this, but now you can't because you forgot the rule. But here's the rule. So, so the b here is 2. The y, and then the x is 1/4. So the b is 2, the x is 1/4, and the y is what we're trying to figure out. And we had a question like this earlier too, right? What question number was it? Can't find it. It wasn't exactly the same, but it was kind of similar. Question 11. This one goes to 11. It's very similar to question 11. What we're going to do is we're going to write this as 1/2 squared, which is 2 to the negative 2. So I'm going to apply some log rules here, or some algebra rules. 4 is 2 squared, and 2 in the bottom, I can bring it upstairs on negative 2, and then I can say that y would have to be negative 2. And that would be B as in boy. That would be B as in boy. Okay, now I'm going to move this down. Don't worry, I'm going to bring it back on the screen in a second. Just giving myself another blank slate to work on. Math people like whiteboards. I don't know if I told you this, but when I'm doing math, I can't do it on lined paper. It's got to be like, I always get a piece of printer paper to do math. I don't ever do math on lined paper. It's got to be just a clean white sheet of paper for me to do math. Okay, number 26, geometry. Okay, so we got a line here, then we got a big triangle, and then a little triangle, it looks like. Oh, and what's really weird about the picture is, what we got here? We got B, A, D, E, C. What's weird about this picture, and this is what you have to remember for geometry. Well, okay, let me say that again. There's something weird about this picture. This line is parallel to that line, and that's going to be a big deal to us. Okay. Because we have this thing in geometry. Parallel lines cut by a transversal. These angles are equal, right? So notice that means some weird stuff here, right? Like, if you look at this here, this angle is going to be equal to that angle. That angle is going to be equal to that angle. Just things I'm just observing right now. And then, of course, this angle here. So before I even look at the question, what I'm noticing is that these are similar triangles to each other, okay? That means the ratios are all maintained and the angles are the same and all that kind of crap, right? So only because these are parallel. If they didn't tell us it was a parallel, then we would know nothing about, there would be no similarity between the two that we could deduce initially. But because these lines are parallel, cut by a transversal, that angle has to be equal to that angle, and another cut by a transversal. Notice they're cut kind of funky different ways. That means this angle's got to be equal to that angle. So angle B, so if I want to think about it, angle B has got to be the same as angle E. Angle D Well, let's do it. Let's do it alphabetically. All right. Just making. Again, I haven't even read the question yet. I'm just still thinking about the question right now, right? Angle A has to be same as angle D because of this rule. And then here, the E and the B. E and the B, not B and B. The B would be equal to B, but that's kind of silly. And then C is equal to itself. Now we could deduce C in a bunch of different ways. So what do I know about this question? What do we have else in here? A is 75. And C is 50. Now, so I know this is 75. So this has to be 75. This is 50. So that one's 50. And then 50 plus 75 is 125. That means that B is 55. Now, how did I know that? Because the triangle adds up to 180, right? So that means this one's 55. Now, let's read the question. I haven't even read the question. Probably did like 100 times more work than we really need to do, right? Let's see what we got here. What is X? Oh, I didn't put X in the picture. E. They want to know what E is. Oh. E is 55. E is 55. And that's the answer to the question. And that is letter C, as in cat. That's letter C, as in cat. Okay. This is the last question for this packet. It's on what's called absolute values. Absolute values are one of those things that I kind of teach in the way that I understood it. So you may have learned how to do this a different way. As long as you're getting the right answer, that's fine. Okay. But let me show you how I do these here. 27. Question is, for what values of X will this inequality be true? You guys, here's how I do this question. What I realized is the answer has to be between -3 and 3. Now, side note, I'm going to digress here again. Actually, can I? Yeah, let's see here. I might want to do the digression. I'll move this over as far as I can there. Let me move the digression far enough away. If it happened to have been absolute value of X is bigger than 3, it would have to be between 3 and 3 that way. That's now again, that's not the answer, that's what I'm thinking. Okay. Actually, what I do is I don't actually know these numbers. These are the numbers I'm going to find. I apologize. I got ahead of myself. I did something wrong. That's right now. What I want to do is find these two numbers. When it's less than, that means it's trapped between the two numbers. When it's greater than, it has wings. Greater than has wings. And again, I apologize. I don't know what those numbers are. I want to find those numbers. Now you might be mysterious. This is not all how I did it. I know, but you gotta trust me on this. So if it's less than, all the graphs look like that. If it's greater than, all the graphs look like that. Now, just some side notes. If it were greater than or equal to, you'd fill in the dots. So you'd include the dots. Same thing here. If there was an equal sign and you fill in the dots. But it's not. So now, why did I do that? The way that I was taught how to do this originally, back when I did this back in Algebra 2, back when I was in high school, the teacher was keeping track of all these inequalities and I couldn't do that. I said, so what I did is I said, wait a minute, every one of these graphs looks like this, and every one of these graphs has wings. So less than is always trapped between the two numbers, and greater than is always bigger than or less than the two numbers. So I had that visual in my head, okay? So what I said is this, wait a minute. So now what I can do is I know that this number, x plus 2, has to equal 3, or this number has to equal its opposite, right? To be negative 3. Notice, again, think about that. What number could this be? It has to be either 3 or it has to be negative 3, because the absolute value, you would get 3. So then I move the 2 over and I get 1. I don't know if you caught what I did here. Now, I know this isn't the way they normally teach it, but this is the way I figured it out, and I'm hoping that this works for you guys. Is I don't have to worry about the inequality. I just set that number equal to 3 and then equal to its opposite. And then, now I do have to put these numbers in correctly. And then I look at that answer and I write the answer to the question. So anytime I pick a number between -5 and 1, whatever's in here will always be less than 3. That's how that works, right? So there's the answer. And I say that is D as in dog. Okay, so this is the first lecture of the second week that I will be out. I wasn't out all of the first week. I was there Monday and Tuesday, hopefully, because I'm filming this actually a lot earlier, right? So there's the answer to number 27. That is it for today. Make sure that you submit your homework for today and to get your points. And then on Wednesday, we will do 28 to 32. And then on Thursday and Friday, depending on what period you're in, we will do the rest of them, 33 to 40. Okay, thank you very much.